I think I'll get started. I'm just going to give a sort of quick and casual overview of Earthmover, our platform, and walk you through some of the new features that we have in terms of data delivery APIs. So let's dive in. We are Earthmover. Oh, okay. Slides are laggy. Okay. We are Earthmover. We are a public benefit corporation, and our mission is to empower people to use scientific data to solve humanity's greatest challenges. So the company was founded by myself and my friend Joe Hammond. I'm the CEO, and we both have a background as practicing climate scientists, and both of us got into this world. By just getting really frustrated with the tooling and the data infrastructure we had available to us as scientists to work with global scale weather, climate, and geospatial data. And so through that work, we got involved in the open source scientific Python world. We started the PinGeo project almost 10 years ago now. And later we founded Earthmover about 3 years ago with the goal of really pushing forward the technology for working with Earth system data at scale. The problem is probably familiar to many of you. We have more and better data about the planet than we ever did before, coming from satellites, coming from autonomous sensor systems, coming from simulations. But the volume and complexity of that data just makes it super hard to work with. So ironically, while we've got more and better data than ever before, folks are also spending more and more time sort of wrangling that data and trying to figure out how to make it actually useful. Let's go to the next slide here, if I can get that to work. So Earthmover really grew out of the open source scientific Python world. Joe and I met each other while working on Xarray, a popular Python package for working with multi-dimensional labeled data sets. And today, as a company, we continue to invest a lot of time and energy in open source maintenance, and we consider it a key part of our platform. Xarray is the sort of user-facing layer of this whole software stack. It's used to analyze and query data, visualization, and it can read and write all kinds of different formats. Now, in the cloud, we are often using Xarray together with Zarr, array storage format that enables efficient subsetting and selection and high performance loading of data in the cloud. And then more recently, we released a new open source project, which is really a crucial part of our platform called IceChunk. And IceChunk is a transactional storage engine for Zarr. Makes Zarr works a little bit more like a database rather than just a file format. And additionally, it brings some really big performance improvements to the whole stack. These are all projects that we continue to work on. Through this open source work, we have, I think, helped set the standard for what the future of Earth system data in the cloud looks like. And this is a concept we call ARCO data, analysis ready, cloud optimized. And so the vision that we're helping our customers achieve is that all of their data is organized in this way into analysis ready, cloud optimized data cubes. Analysis ready means the data are already sort of stacked into these neat, easily sliceable cubes, and we don't have to think about the individual underlying files. And then cloud optimized means that we can work efficiently with those data structures in the cloud, do subsetting, understand the metadata, and achieve high throughput and low latency. But what we've seen is that just simply having this concept of ARCO data isn't really enough to enable organizations to implement it and reap all of the benefits. The core challenge that most of our customers are facing is how should we actually store, manage, and query these ARCO data cubes in an operational context. And so some of the options that folks consider within this landscape are to use an existing data warehouse or data lakehouse technology. This is something like Snowflake, Databricks, BigQuery, and those are really great products, but the problem is that they don't really understand this data cube model. They don't understand multidimensional arrays. And so trying to squeeze your ARCO data cubes into a data warehouse is a really awkward fit, and it comes with big performance penalties. The sort of standard option that then most teams pursue is to build their data system on top of cloud object storage. something like S3. And that can definitely work, but it requires a lot of custom engineering and maintenance to build a full data platform on top of cloud object storage. And so what we're offering is intended to be the sort of best of both worlds here. A turnkey solution that doesn't really require a lot of custom development and maintenance and allows you to just go from 0 to ARCO data cubes overnight. It offers integrated geospatial APIs and best-in-class performance for array-based workloads. And it's really built for Python, AI, ML, and data science workflows. So here is a view of what our sort of platform architecture looks like. You can see the platform, sort of sits on top of cloud object storage. So this is really the only requirement from a customer is that you want to use cloud object storage in any cloud or including an on-prem cloud. Our platform reads and writes ice chunk data from that cloud object storage. And then layers a bunch of services and capabilities on top of the raw data. So we have Array Lake, which is our sort of data catalog and data governance layer. So it provides data discovery, access controls, metrics, and logs. Then we have Flux, which is an API layer that provides the ability to query your data in a range of different ways. And then something we're sort of starting to build now is we call our engine, which is a more compute-based capability that provides ingestion, data transformation, and views on the underlying raw data. On top of this, our users are able to layer big data analytics, data science, and ML, AI model training and inference, building web apps and dashboards, and really doing open science on top of their cloud-based data. So some of the key problems that we're solving with this platform are the following three. Many folks who are trying to do cloud today find themselves with a data swamp, a big jumble of different files and processing steps that is really hard to reason about and understand. And so our platform enables folks to adopt this analysis-ready, cloud-optimized data cube approach through a centralized data catalog, transactional updates, and all of the access controls and audit logs you need to really put that sort of solution into production. Performance is really the foundation of a lot of this. Using archival file formats like NetCDF and HDF in the cloud can lead to really underutilized CPU or GPU because you're really limited at the rate you can read data from those formats. Instead, by using Earthmover, using ice chunk, you're able to get really high performance I/O, and I'll demonstrate that in the demo right after this. And then finally, we make it really easy to deliver data from your data store into downstream applications, databases, and dashboards. And so we do this by providing OGC standard APIs, which serve up that data through a range of different protocols. Specifically, we're currently offering the following three protocols in the platform. OpenDAP, so this is a protocol that's been around for a really long time and is therefore very interoperable with a bunch of different tools, languages. So OpenDAP is server-side subsetting of NetCDF style data sets. Our most popular one is tiles. So these are dynamically rendered map tiles with custom styling and color maps and all of that stuff. So this allows you to integrate your data into web maps using Leaflet or Mapbox, also into desktop GIS, like QGIS or ArcGIS. And then finally, my favorite here is something called environmental data retrieval, EDR, which allows you to query these data cubes at points or within polygons and pull back basically time series in JSON, CSV, or Parquet format. So I'm going to sort of walk you through what this looks like, just to give a sense of how our customers are using this in production today. What we find is most of our customers are doing some sort of AI-driven physical modeling in which they're ingesting some sort of raw data into data cubes in Array Lake, doing processing and feature engineering, model training, and inference, and using Array Lake to manage the data throughout that lifecycle. And then finally, delivering data to downstream apps or dashboards or different stakeholders through either directly through Python access or through the Flux-based APIs. We're proud to have some of the top AI and data analytics companies in the world using our platform for some really advanced and sophisticated stuff. The demos that I'm going to show you today are really motivated from what we've learned working with them and the best practices that we've seen. Finally, before I switch over to the demo, I just want to mention something that we've got in the works. It's our data marketplace. So one thing we've observed from working with our customers is just how much effort goes into ingesting and consuming data sets. And so we're building out this data marketplace functionality to make it really easy for different types of organizations to exchange and share data in a cloud native way. And we're going to be starting off with weather forecast data from ECMWF. This is something new that we're excited about. Okay, so I'm now going to switch over to a little demo. And what I'm going to do in this demo is just sort of walk you through the platform and show how we actually ingest data from scratch into the Earthmover platform. So here is the sort of dashboard that a user sees when logging into the Earthmover console. You can see we're connected to a bunch of different cloud storage buckets. And so we're managing data across a range of different clouds. We've got our organization members where we can see, who has access and what type of roles they have. And then we've got a bunch of metrics here we can see about how our data are being used and queried over the past month or week or day or whatever it may be. The data themselves are organized into repositories or repos. And so what I'm going to do right now is walk you through the process of actually creating a new repo and ingesting some data into it. So I'm going to do this by running this Jupyter notebook in the cloud. I'm going to just restart this and clear this. And before running this, what I've done is I've logged into the Array Lake platform. And so you can see I'm actually already logged in. That is going to allow me to interact with the platform through the API. And so what I'm going to do here is just import the Array Lake client. And then I'm going to create a new repo called ECMWF IFS Opera. So I'm going to create an example data set ingesting some ECMWF weather data. And then I'm going to populate that, and then I'm going to go back into the web and look at the data and interact with it through the Flux APIs as well. And so here's just a big block of code for actually downloading the ECMWF weather forecasts. I'm not actually going to walk through every line of this code. I'm just going to run these cells, and I'm going to specify a specific date where I want to ingest these forecasts. And then I'm just going to start downloading those files and loading them with Xarray. And this is going to take a little while. And this is kind of part of one of the reasons why we would want to ingest the data and transform it into ARCO data cubes. Even though this data is even already in the cloud, these are stored as GRIB files. And so accessing those GRIB files is relatively slow. It takes a while for us to download them and load them and actually make them useful for analysis. And so it's going to take us about a minute to load 100, or rather something like 40 forecast steps. And then we're going to compare that to once we get the data into Array Lake. So this is almost done here. This is sort of the longest step that I have to run here. And that last straggler is done. So now I'm going to open these with Xarray. And we see we've got sort of a forecast data cube here. This is what I'm going to write into Array Lake. We've got forecast time, forecast step, and then we've got 20 or so different data variables that we're going to load. And so I'm going to write this now to Array Lake. We're using IceChunk to mediate this write. And we are storing it just using the Xarray standard API. So, just calling to Zarr on this data set is enough to get the data into Array Lake. Once that's done, we sort of commit our changes, and then we're ready to look at that in the web. And so here we'll pop over to the web console. We can see the data set we just ingested. We can actually see a full history of this data set. We can look at the different variables, and we can look at their metadata. And this is the Array Lake catalog. In a minute, we're going to go look at some of the data access options that we have. But first, I'm going to just go back and interact with the data through Python now that it's already been loaded into Array Lake. And so here we show you the code you need to get your data back out. It's just simple Xarray code. Oh, wrong tab. I'll go to my notebook here. And so now I'm going to open this data set back up with Python. You see the data set opened essentially instantly from this repo. And we have the same data set. We can really quickly select data however we want. So here is a map of precipitation. I can also pull out a time series just as easily. And if I actually want to load the whole data set into memory, I'm going to just time how long that takes me. This took me 4 seconds to load 3.6 gigabytes of data. So this is loading data at close to 1 gigabyte per second on just this little VM. So compare that to the, almost a minute it took to download all of these GRIB files. And so this is kind of what we mean. This is really built for high performance data access, high throughput, and low latency. Okay, so now that we've got the data in, we've queried it from Python, but we can also query it through these Flux APIs. And so if I go back to this data access tab, we'll see I have various options, whether I want to use OpenDAP, EDR, or web map tiles to view my data. And so let's do the tiles because that's fun and interactive. So I'm going to pick this variable precipitation rate. I'm going to specify a color scale range that I want to use to render the data. And that's it. I can click preview, and I've immediately got this nice interactive web map that shows the precipitation rate from the model on a nice Slippy map. Now, while this is an interactive data visualization widget here in the browser, this is really designed for developers to be able to build their own data visualizations. So we give you the code you need to build a web page with this, and we show you the actual tile URLs or tile JSON URLs that you would need to bring this into any type of GIS application or web map application. And so that is tiles. And then the other one I want to show is EDR, environmental data retrieval. So here is where we can specify just a range of points or areas that we want to query. So I'm just going to add a bunch of random points. And I'm just going to, imagine these are things that I want to where I want to retrieve data. I'm going to select some different parameters. So let's get our pressure. Let's get total precipitation. Let's get some solar radiation, and then we can select our format. So CSV is a very useful one. So we'll just grab CSV, and at this point I can just click download and download a CSV of my data. That has downloaded, so that's not very interesting to show in my demo. What I'll do instead is I'll copy this URL and I'll go over to a spreadsheet here, and I'll just plug it in, and I'll just import this data directly into a Google Sheet, right? And so now I have bridged the gap between my data set that's stored in Array Lake in my ARCO data cube, and my my spreadsheet or a downstream database application like that. So that is my lightning fast demo. I want to point out that the data set we created here is not immutable, but in fact, we can continue to build on it and extend it. And that's the whole vision with the platform, is to treat the data more like a database rather than a collection of files. So when the next forecast comes in, we can append it and we can continue to query it through all of those same interfaces. Okay, so that's the little demo. I think I will stop here, and if folks have questions or comments that they want to share, we can kind of open it up to the audience, and we can answer any questions that people have. I don't know exactly how we do that. Maybe Cheryl, do we have a sort of hand raise, or can people just go on camera? I don't know how it works.
Yes. So we do have the Q&A, so you can just click on Q&A. And I believe if anybody needs to prefers to ask a question verbally, I think there's a button there that I can click to open up the verbal stuff. I don't know. We'll find out. We're new to Zoom.
Yeah, we recently moved platforms. Had been using Google Meet and we switched to Zoom. So yeah, I thought I might have seen a hand go
You
up at
do,
some
you've got
point.
yeah, you've got a nice big 5-part question here by Jordan.
Oh,
Yeah, if you click
okay.
on Q&A.
I got to figure out how to see that. Okay, I think I've got it. Okay, Q&A. Great. Okay.
Yep.
Okay. Jordan is asking a bunch of interesting questions. Okay. Does Array Lake support GPU accelerators? Um, Not right now. I mean, you can certainly easily load your data into a GPU. So I guess it depends on what exactly you mean by that question. Um, we can load the data into a GPU very quickly, and that's what everyone is doing in machine learning workflows. Array Lake and IceChunk are, ultimately these are transport protocols, and they go over the, HTTP, and so, that processing has to go on the CPU. And so the typical workload is, use the CPU to load data from storage and then move it to the GPU for processing. And so I don't know if that answers your question. Does virtualize Zarr aim to support dynamic chunking or even multiple chunking, different delta like Parquet indices for the same underlying data store for different use cases, time series versus maps? I think I see where you're getting at, and the answer is absolutely yes. This is not necessarily a virtualize R question. This is more about IceChunk and Array Lake. And yes, the weather data products we're currently building implement this sort of multiple chunking approach. So love to learn more about your use case there. These are a bunch of really interesting questions. Does XPublish aim to support custom grids beyond standard Mercator or plate Kerchunked ones? So Xpublish-tiles supports a wide range of different grids. It's definitely not just Mercator plate Kerchunked. So we support most standard projections. We also support Gaussian grids. And so the data certainly don't have to be in lat long or something like that. And that goes for both the input data and the output data. We have the output option to generate tiles in a range of different projections. Is it in the works to be self-hosted? That's a complicated question, HPC and Ceph. We are very focused on the cloud today. And so I think we have a roadmap to have this be self-hosted in a virtual private cloud. I don't think we have a roadmap to move this whole platform to run self-contained on an HPC system because it just doesn't offer the same type of capabilities and dynamic scaling features that you find in a cloud environment. So that's a somewhat complicated question. And does Earthmover have any monitoring utilities? Yes, we have a ton of monitoring utilities. So if I go over into these metrics here, I can actually see all of the usage. I can go in the past hour. We can see the exact usage of this data set. And we can understand who's been querying what and which data sets are popular and all of that stuff. So that is a bunch of questions, Jordan. I hope I answered them. Would love to follow up with you if you have. I get there's probably something more behind some of this, so we'd love to sort of sync up with you and give you more information. But I'm going to move on to the next question. Nathaniel is asking, is this primarily aimed towards traders or weather providers? That is a great question. And this is something, honestly, that we have wrestled with a little bit as a company is which is the right type of profile to focus this platform towards. Now, the answer is both. So what we are trying to do is create a platform that makes it really easy for weather data providers to get their data into the hands of data users and for data users to make that data more useful within their organization. And so what this means is that we are building features that allow traders, commodity traders, energy traders to activate their weather data, and weather data providers to get their data to those users very efficiently. So I'd love to tell you more about what we're building in this space. Okay, Sagan is asking, does ArrayLake optimize transfer and transaction costs for cloud storage? Does it automatically optimize chunking, or is it up to the users? That is a great question. We optimize performance, and we help make the data flow from object storage into the client as efficiently as possible. It does not automatically optimize chunking, but it works well over a wide range of different chunking schemes. So this is something that we're working towards, is the automatic chunk optimization, but it's a pretty complicated problem space. Okay, and I've got another question here from Enrico. What are the requirements for an existing data set to be successfully imported into ArrayLake? It has to be able to basically be read with Xarray or NumPy. So if you can open your data in Python and get it into NumPy array or an Xarray data set, it can be imported into ArrayLake. It's not aimed at tabular data. There's a lot of tools for tables, and so if you're using pandas or something like that, there's other databases that you can and probably should use. When you show 3.6 seconds to load into memory, this is from a VM. This is just like a standard EC2 machine. We're actually using Coiled to run this notebook that's just running in the same cloud region as where the data are stored. So you can query the data from anywhere, but you get the best performance if you do that from a data proximate location within the same cloud region. Okay, could you say a few more words on how it solves the first problem, data swamp? How are data sets harmonized? How does working with different data sets with different standards look like? Yeah, so we help harmonize data by requiring that all data be conform to the Zarr data model, as in you're storing arrays and groups. Within that, we're flexible. So what we eliminate is this sort of swamp of different file formats where you have a bunch of different file formats and a bunch of different readers to read them. All data in ArrayLake are stored in essentially the same data model, same format, and can be, once you have them in there, they can be queried and managed. It doesn't fully automatically make your data organized. You still need to put some work into defining those schemas and figuring out how you want to leverage the platform, but at least they're all centrally accessible through a single API and through a single data model. What is open and free and what is not? Great question. Yes. So what is open and free is the open source, right? Xarray, Zarr, and iChunk. These things are all free and open source. And then what is our product is the platform, which you pay for like any software subscription. So that is that's the relationship there. I think we've reached the end of the half hour. And so I really appreciate all these questions. Obviously, we'd love to connect with you. And, if folks are interested in a demo or rather in a more customized demo or a trial of the platform, we would absolutely love to support that for you. And just we'll be following up with everyone who attended. And if there's things we can do to help you learn more about the platform, we are very much open for business, and we're happy to support new customers, adding new folks by the week. So thank you so much. We're going to have to wrap up here. Jordan, I see you have a few more questions, but I think we should probably schedule a follow-up meeting to address some of those. So thanks a lot, everyone, for your time.